Hi everyone, welcome to the series Let's Get Solving with Google Cloud. In this, what we are going to do is we are going to have 8 problem statements and we are going to solve them with the help of Google Cloud. So we are all in IT, whether we are doing database development, website developments, we are creating data dashboard, we are creating a regular application, or we are doing machine learning. We can all change how we do that with help of cloud. And what is the power cloud gives us? That's our aim in this series. We are going to see how do we modernize our infrastructure, how do we modernize our data infrastructure, how do we modernize our application development, and how do we modernize our AI. AI is actually modern. We just have to use the word modernize there. But this is the kind of like crux of this series. Taking a problem statement and reverse engineering, how do we use products to solve that problem? That's a different perspective here. So my name is Ajinkya Kulle. I'm a machine learning and data engineering instructor at Google Cloud. So I teach people, how do we use cloud products to leverage the power provided to us by it. So whether it is using BigQuery for data warehousing, or whether it is using TensorFlow for machine learning, or using Kubeflow, or using AutoML. AutoML is the best. We don't have to spend a lot of efforts and we get a lot of results. We get a lot of ROI on less efforts we have put in. So you see, how do we do that? How do we get started with using Google Cloud to actually solve the problems? That's my job to teach that. And in this series as well, that's my job to take a problem statement and actually help you understand how to solve that problem statement and go ahead. Okay. So going forward, it's like the application which we are going to solve today is this. Build an application in a cloud agnostic way. Okay. Let's divide this problem sentence and chop it into 3. Okay, first part, build an application. What application are we building? So my hypothetical company is my blog. Okay, so I'm hoping to make my blog a bestseller, not a bestseller, a million visitor blog or something. Let's say I want to do that. And for that, I have simply created a website, I'm hosting it somewhere, and that my plain HTML website is my application. So how do I build that application? What is the traditional way? I would have hosted a virtual machine somewhere. I could have hosted here on my laptop. For that purpose, I would have had to take an external IP, install the Apache server, expose it via DNS or something. That would have been my headache. I would have to keep my laptop always on because it is going to be serving the request to whoever was the customer. Now that's a headache. My laptop kind of like is limited to only doing that, and maybe I won't be able to shut it down. So I would rather use a server, right? So instead of using a laptop, we start going to server. Server's job is what? Doing this thing. That's its job, right? So that server could be hosted in my home somewhere, or it could be hosted in somebody else's who is providing me the server. Okay. Now, what was the next phase of the migration? When this technology evolved? It was cloud. We have a server. So that server on my data center, that's my data center. Then it is somebody else's data center. Now it is cloud's data center. What's a cloud? It's nothing but an abstraction. Like I said, cloud computing is nothing but the abstraction over computation. Okay, so if I want to store something, if I want to execute something, wherever it is going to need, whatever it is going to need, it's taken care by whoever is providing me, the cloud provider, right? So in this scenario, it's cloud. It's Google Cloud. Okay, so when I am using Google Cloud, what I'm using is I'm using Google Cloud's data center. And this data center is being used by Google for all its application, right? So we are guaranteed the high SLA. Now, again, the next stage of evolution is cloud agnostic way. So people move to cloud, and then if you actually get locked into that cloud, now you have sacrificed your flexibility for some ease of use. If that is not the sacrifice you want to do, then building then applications in a cloud agnostic way is our only option. We want to build it in such a way that I'm not locked in. I can change it. I can go from on cloud to on premise. I can go from on premise to a different cloud provider. I can move from that cloud provider to again back to on premise. That's my job. So in the end, what we want to do is like we want to build an application in a cloud agnostic way, and that application is a website, right? So this is not going to be just a hypothetical discussion. We're actually going to execute the labs as well. And we are going to use Qwiklabs to execute the labs. So as a kind of like a incentive or as a way for you to execute this Qwiklab, what we have created is we have created a campaign. If you go to this link, bit.ly/2 capital Y 1 small j small b capital B capital J. Go there. If you have a QuickLab account, great. Sign in with that username and password. If you don't, sign up, create a new account. Okay, so let's just do that. Let me go here, open this link. This should redirect you to a QuickLab place here. So you see, this is google.quicklabs.com. This is different. If you now check a title, okay, this is different from quicklabs.com. When you create an account here, it's going to be same credentials, of course, but it gives you 1 month of pass, 1 month of access to execute any labs you might want to execute. Now that's a great way. If I go back here, if I open google.quicklabs.com, and if I go to catalog here, and if I check, Google Cloud environment and check any format thing. So as you see, around 500 labs are available here, which are, available for us to do whatever we want. That's a great learning resource, especially in this time where we're all working from home. This would be a good time to refine our edge, if we already use Google Cloud, or build an edge if we haven't used Google Cloud. So it's a win-win for both. Okay. So follow this link, which is this link, and find the lab which you want to execute and start using that lab. When you are opening this thing for the first time, it will kind of like redirect you to a video, how to use Qwiklabs. If you want, you can search the same thing on YouTube and you'll find a video. Okay, that's a good way to do. Now, what do? Let's say you find a lab which is fun, which you are interested in, which matches with what you have been doing in your job. Okay, you want to do that lab. So you find that lab, you click on a start lab. Okay, and then, okay, let's just show. I'm going to do not a quest, all quest I'm getting. Let me select a hands-on lab here, and I'm going to take first lab, a tour of Qwiklabs and Google Cloud Platform. So you find a lab you might want to execute. It could be anything, and you click on start lab. After you do that, what happens is you get this free username and password. If I want to experiment with Google Cloud, okay, I can create an account there and I get, free credits, whatever credits, depending on whatever my location is. I'll get certain amount of free credits. But I do have to put in my card information. It could be debit or credit card. Using that information, it acts as a backup. Whatever I use on cloud, it's kind of like gets consumed through those credits. But just in case those credits get finished, we want that credit card or debit card. And that's, if you don't want to do that, it's the best thing to use this QuickLab username and password. Why? Because here you don't have to give anything. The billing is taken care. So it's a free pass for me to kind of like use Google Cloud and learn it, get the hands-on feeling. This hands-on feeling is what is very important, right? Knowing how to cook and actually cooking are two different things. I know that now. The masala, if I'm trying to put into my food I'm trying to cook, I never can get it right. Knowing how to swim and actually being able to swim are two totally different things. When I was learning swimming, it's like no matter how much I practiced outside the water, that practice did not carry inside the water, right? So what we want to do is like we want to actually get hands-on expertise, not hypothetical and theoretical expertise. This is the tool for that. Okay. So how do? We click on start lab, copy this username and password and enter this username and password in incognito window. Incognito window is essential. Okay. Why? So I've gone into incognito window and going into console.cloud.google.com here. Okay. Let's just copy paste this username and password. Okay. So what's happening here? This is a temporary Google account. Okay. Now, if you're using Chrome, most likely you might be one of the most widely used browser. So what happens is, if I sign in, I sign in with my account. You see, this is my profile, right? So my profile might get in conflict with this free username and password. So I might be thinking that I'm using a account in which I don't get charged anything, but accidentally I might, because here in this, if I use, okay, so this account which is created, right? So this account is only QuickLab account. If I was using it in non-incognito window, what would have happened is there would have been my account here as well. That would have given a problem. Okay. Hence, use a incognito window always. That's number one important thing. Okay. Number two, after you sign in, what you have to ensure is that you select a project. Without selecting a project, you are unable to do anything. Okay. So I'm selecting a project, and here there are a lot of project names here, so you have to select a project which begins with this Qwiklabs GCP 03. Okay, and that's a surprise that I'm not seeing that project, but as you know, things always go bad during demo. Whenever I'm doing it myself, it never goes wrong. I'm hoping that I actually see that project, but apparently I do not have that project with me. Okay, let me. Okay, let's just create a project ourselves. Okay, I can't. Okay, let me just log in again then. Okay, let's end this lab. Ooh, let's log in with this credentials. So the lab which we are going to do is, let's go to those details. Okay. So the lab we are going to do is Kubernetes engine Qwikstart. What's this lab? So the hypothetical problem statement which we are trying to solve here is, I have my website which I have hosted somewhere, but I want to change that and do it in such a way that it runs on cloud in a cloud agnostic way. Two things. It runs on cloud in a cloud agnostic way. So hence the lab for it is Kubernetes engine Qwikstart. Okay. So I'm signing in with the for this lab. So I have already searched this lab on the QuickLab which we are using, which is on google.quicklabs.com, and I have started the details. So let me copy username and password, and I'll have to sign in with that because I was using the wrong one before. Sign in. This is QuickLab user, this is QuickLab password, and now I should be able to actually see this project which I talked about last time. So the project is QuickLab underscore GCP something. We should be able to see that here without any problem. So let me accept the user and license terms and select the project. See, the project is back. Anyways, let's scroll down, scroll down, scroll down, scroll down. These are the lab instructions, and the lab instructions we want to follow from here. Okay, setting the default compute zone. Okay, so what's happening? When I say give me a machine, where is the machine which is being given to me? That's this compute zone I'm talking. So we are just setting up, okay, whenever I say request something, I want this default to be set something. And let me just, hide my navigation menu and open Cloud Shell, which is on the right hand side of search bar. Okay. What is a Cloud Shell? It's nothing but a virtual machine, Linux virtual machine, which is given to me for free. Okay. It's like, this is what I'll use to interact with Google Cloud. So all this is kind of like, getting started of Qwiklabs, and we will kind of like use this now to solve the problem. Okay. Let's just execute this. Okay. So compute zone is updated. Let's create a Kubernetes engine cluster now. Okay. We are being asked to create a cluster whose name is my cluster. So I'm copy pasting this. Oops. So you see, right now the Kubernetes engine is being created. Okay. Now let's just see some understanding of what's a container, what's a cluster, what's a Kubernetes. Okay. Let's say I have my website. My code of website is this. Okay. So this is my website code. Okay. Now that code is running somewhere. That is the infrastructure. Okay. Now let's say my code needs some libraries to run. Okay. So my code, the libraries and everything, I can put it into a box. Okay. So that box becomes a container. a container which contains the code and also the libraries and everything that code needs to run. Okay. Now, this is the container which is nothing but my whatever thing I need to execute. So that's the code part. Now, where it is being executed, it's on the Kubernetes cluster. Okay. So if let's say there is a more demand coming to my website, okay, what's going to happen? To meet that demand, I need more computational resources. How do I meet that? I clone the container. I mean, I run it on a cluster. So, it's like new resources get allocated, or they are already present. They just get assigned. And there my container is running. The container is going to meet the demand of whoever is requesting my website, right? So you see, even though it sounds complex, the code, put the libraries, make it container and deploy that container on a cluster with help of Kubernetes, it's complex. But what it gives us is a power to auto scale. If my website traffic grows, it's going to automatically increase the computational resources based on whatever my config I've provided. And the best part, I don't have to do that manually. Kubernetes has all those settings inside it. That's the fun part. So it is complex what we have in Kubernetes. It is definitely complex. Okay. But the features we get there, they make it definitely worth it. Okay. So if I scroll down, okay, I'm not going to scroll down. I'm going to scroll up. So if you go into overview part, we can actually see these are the features which Kubernetes gives us. Load balancing, automatic scaling, automatic upgrade, auto healing, logging and monitoring, all by default. Right? That's power of Kubernetes. Right? It's nothing but it's doing work for us. Of course, I have to do the command line and kubectl, and I have to have that knowledge. But after I have that knowledge, my lot of manual efforts and time, it's not needed. Okay. I know I was on the QA team wherein the releases and all that headache, monitoring, cutting the release branch, it's a headache. Trust me, it's a headache. But Kubernetes can make it a lot easier. Okay. So we have created a cluster here, and below is kind of like how do I make it so that I can access that. Now, as you can see, when I'm using Kubernetes, I can kind of like simply say check my progress, and it will kind of like tell me whether I have completed the instructions correctly or not. Now, I don't know why it's not coming correctly for me, but that's just luck. Okay, let's just execute my cluster. So this thing is going to make our Kubernetes cluster and configure it to access. Okay, this has been done. And now this is where the simple website, I'm actually deploying it on my Kubernetes. Here the commands which are being used are Kubernetes commands. So if you notice the command which we executed before, the command which we executed was this gcloud command. I have just highlighted that. Okay, so this was Google Cloud command, create a cluster. Now once the cluster has been created, okay, once we have configured the cluster for access, now it's all Kubernetes command, which is nothing but kubectl. Okay, so we have created this thing which is like remember I said code and I put it into libraries with containers. That would be my website image. Here it's this sample image. It's on gcr.io. Hello world. This website doesn't contain anything. It's simple website. Okay, so it's like but how do we do that? So it's like when you are executing, you should check the progress. You'll get marks. Do all of those 8 laps, you get a badge. Okay. Now let me see this thing. This command is creating few things. It's one, exposing the website which has been deployed on a certain IP. Okay. And it also kind of like creates a load balancer. So you see, when I said I have to have a load balancer which is going to check how is my utilization of my cluster. Do I need more machines? How much is my demand? How is my utilization? Okay. Let's say I have a huge cluster and my utilization is low. I need to scale it down. So that's all part of job of Kubernetes. Okay. And I can configure myself to scale up and down according to the demand. That is great. Okay. Now let's just see how much time it takes for it to create. And let me just execute this command to see whether it has been created publicly or not. It is done. So let me take in this IP, and it is 8080. So now I don't have a stress testing environment set up, but was it 8080? Okay, it was 8080. Nah, why is this not working? 34 66 24 20T. HTTPS. Okay, so it's like HTTP external IP, this thing. Let me just execute it here and let me copy paste the IP. Maybe it's the incognito Windows fault. I mean, I don't think it should be, but who knows, right? I don't have time to debug it here. Oh, yes. Right. So the website is deployed. Okay. This is simple hello world website. Okay. Now what's happening here? Let's check into the lab instructions. So this has been done and my Kubernetes cluster is created. Now here we use Google Cloud. I might as well use it, some AWS or Azure or on premise as well, as long as I'm using Kubernetes. It's an open source library which allows us to minimize the work we are spending managing our infrastructure. Okay, and the fun part is scale. Remember, we simply created website, but what it gives us is ability to scale. Let's give me an example. So this is the analytics of my website. Okay, in past 7 days I've just had 33 users, so it doesn't matter how much small compute instance I allocate, right? Even my cell phone will be able to handle 100 times more traffic than this, right? But if it did scale to higher number, okay, automatically scaling the infrastructure to the demand will become job of Kubernetes. Now that is great. Example for that is kind of like this tweet. So this tweet was taken back in 2014 by Ellen in Oscar when she was hosting Oscars. So remember, as you see this tweet, it got 3.1 million retweets, 2.2 million likes, so much traffic that it actually caused Twitter to crash. Example of auto scaling. Since then, we have had a lot of upgrades in how infrastructure is being created and used. So what we want to use is we want to use a system which allows me to do everything automatically without much manual intervention. Okay. So similar example happened on Instagram. There was this picture of an egg which had such a huge activity that it was insane. It was much more than the tweet we have had. You see, when the technology upgrades itself, okay, the power we have is a lot more, right? So this is what is happening here. We have this Kubernetes engine which is allowing us a powerful way of building applications in a cloud agnostic way and in a scalable way, right? So this is what we want to do. So this was our lab in session 1, where what we are doing is we built an application in a cloud agnostic way. So in next session, what we are going to do is we still have that website, which I'm hoping that using deploying it via Kubernetes takes my job away. Because why? I'm hoping for a scale. Now, if I want to reduce my network expenditure, my CDN, or I want to optimize by reducing my latency, I can do either of two things, right? So in next session, we are going to see how can I do that optimization on Google Cloud. Stay tuned and see you in session 2. Thank you.